Hello, welcome back to my YouTube channel. I hope you are all doing great. Today we will be looking at MATLAB. Today we will be looking at matrix transposition, inversion, and indexing in MATLAB. So without further much ado, let's hop right in. So as usual, I will open my MATLAB, right? And wait for it to open, right? Then I will navigate to my workspace or the folder where I keep all my files. It makes my files more organized. Maths, okay, this one, select, all right. So as you can see, the scripts that we last worked on are displayed here. So for today's lesson, let's start a new script, right? Then Control S, then we give it a name. So let's call it matrix transposition inversion and indexing, right? So we will first start with matrix transportation. So trans matrix transposition rather. So first start with matrix transposition. First of all, when we see matrix transposition, what do we mean? It is basically interchanging the rows and columns of a matrix. We all know that a matrix is an array of elements consisting of number of rows and the number of columns. So when we take a certain matrix of a specific dimension and we swap the rows and the columns, say we've transposed the matrix. So let's consider a matrix a 3 by 3. No, let's consider much more. Let's consider a 2 by 3 matrix. So a 2 by 3 matrix. Let's fill it with numbers. So 1, that is essentially 2 rows, 3 columns. 2, 4, then 5, 7, 8. So what we are looking at right now is basically a 2 by 3 matrix. That is a matrix consisting of 2 rows, 3 columns. So let's run it so that we see it clearly. As you can see 2 rows, then 3 columns as intended. So how one will say, how should we transpose the matrix, or how should the matrix be transposed? In order to transpose a matrix, we use a function called, there are two ways to do it. The first is by making use of a function called transpose. So how do we do it? This is how we do it. So assuming Q is the transpose of A, just type Q equals transpose then A. So let's display it so that we see it. Q. So let's remove the suppressor here so that you can see the things clearly. So run it. As you can see, let's see. So as you can see, A was initially a 2 by 3 matrix, meaning that consisting of 2 rows and 3 columns. After it was transposed by passing it as an argument to the function transpose, it was later transformed into a 3 by 2 matrix. So essentially, we have 3 rows, 2 columns instead. So the a much more way to verify this is by getting the dimensions of the two matrices. In order to get the dimension of a matrix, use a function called size. So in order to get the size of the dimensions of the matrix, we use function called size. But before that, let's make our work a bit more organized so that you will see the display clearly. So let's say original matrix. This one to this one. Let's clear the command window, then we run. So as you can see, we have the original matrix here, which is 2 by 3 matrix, so consisting of 2 rows and 3 columns. Then we have the transposed matrix, which consists of 3 rows, 2 columns, implying that by passing the original function A to the transpose function, the value which was returned and assigned to the variable Q was basically the transpose of A, that is a matrix identical to A, but the dimensions were swapped. So basically that's what happened. The rows were swapped, the rows and the columns were swapped in order to get the transposed matrix. So in order to verify this, you can we can determine, or we can extract the dimensions of the two matrices. And to do that, we use a function called size. And this returns an array of elements, or basically a list of elements. In this case, the elements being the row and the column. So when you pass a matrix to the size function, it will basically return the number of rows and the number of columns as a list. To basically return the number of rows and the number of columns of the matrix passed to it as a list. In this case, we want the dimensions of the first matrix, which is A. And since it is a list, MATLAB allows this, so we can assign it to a list. So in MATLAB, an array, let's use array because it's more appropriate. So in MATLAB, an array is declared using square braces. So because size, which is a function, returns an array consisting of the rows and columns of the matrix that was passed in, you can basically assign it to an array directly. So then we just put in the variables to indicate the rows and the columns. So row, comma, and col. So this will essentially give us dimension. So this will essentially give us the dimension. Let's take it. Give us the dimension of A. Similarly, if we want it A, then ask for A. Yes, we are also trying to get the dimensions for the dimension of the transposed matrix, which is Q. So Q, comma, col underscore Q cos size, then you pass in the transpose matrix, which is Q. So this will basically give us the dimensions of Q. So now In order to now let's in order to display the dimensions for us to see that the rows and the columns were swapped, we make use of a display function. In this case, not a disp, but a function called fprintf. And what this function basically does is that it allows us to output to the command window and also write to a file formatted strings, that is strings that we format that can, let's say, custom strings. So it allows us to output formatted strings to the command window and also to a file. But mind you, we can't use fprintf to print matrices to output matrices. It only works with strings. It works with strings, formatted strings. So size of the column. Also, another feature of the fprintf is the use of placeholders. Obviously, as I have already said, the fprintf allows us to display formatted strings, and in writing the strings, it is allowed to use certain placeholders to represent certain data types like integer strings, which will be injected into the string and outputted to the command window when you run the program. So one of such placeholder is the %d. %d basically means a decimal, basically means a decimal, or let's say any integer. That's basically what the %d means. So the %d is for whole numbers. That is any whole number that we wish, not a decimal number, a whole number that we wish to insert into the string at runtime or when we run the program. So percentage, so in this case, we want to output the row and column, the number of rows and columns in the string at runtime. So the first placeholder for the row, then X, then the second placeholder for the column. Then after that, you close. After that, you enclose it. You close the quote with the ending quote. But we want a new line to be displayed so that the display \n, then a comma, then followed by the row underscore a, comma, call underscore, then you close it. So to use the fprintf, you write the string that you wish to be outputted to the screen, then you place placeholders. That if you want to insert whole numbers into the string at runtime, you place the %d, which is a placeholder at the positions where you want the numbers to be inserted. Then at the end, after the string, input the variables containing the values you wish to insert in the string in the order you wish for them to appear. So in this case, we want row first to come, followed by the number of columns. So this is for A. Let's do the other for Q2. So size of Q %d x %d, then \n for new line, row Q all Q. So let's clear the command window so that we see the code clearly. So phase 2. Now let's run it and see. Alright. But before that, let me comment this one that you see, can only focus on this part. So let's run it. So as you can see that The size of A was initially a 2 by 3 matrix, which is consisting of 2 rows and 3 columns. Then after passing the matrix to the transpose function, we got a 3 by 2 matrix, implying that the rows and columns of the original matrix were swapped in order to get the transposed matrix. I hope you all understand. So at the beginning, I said that there are two ways to transpose a matrix. The first is to make use of the transpose function. Then another way to do it, so let's comment this one. Then we still use the kill. So the other way is by writing the matrix followed by a single quote. So let's see if you get the same thing or the same result. So as you can see, we got the same result. The dimensions of A or the dimensions of matrix A, 2 by 3 matrix, then the dimension or the size of Q came 3 by 2 matrix, meaning that the matrix of A was transposed by this expression. So take note, there are two ways to transpose a matrix in MATLAB. The first is to use the transpose function, then pass the variable containing the original matrix as an argument. The other way too is by writing the original matrix or the variable containing the original matrix followed by a single quote. Both of them will achieve the same result. So that is basically how transpose of matrices is implemented in MATLAB. Now let's move on to matrix inversions or inversion of matrices in MATLAB. So matrix inversions. So when we talk about matrix inversions, for matrix inversions or matrices inversions in mathematics, there's usually a lot of processes involved. If I recall correctly, you will need to find the determinant. Then if supposedly you are dealing with a 3 by 3 matrix, you will have to then you have, if suppose you are dealing with a 3 by 3 matrix, you have to go further to find the matrix of cofactors, transpose it, and all. There's a long process. In MATLAB, there are certain functions which makes finding the inverse of a matrix very, very easy. And mind you, not all matrices are invertible. So the functions in MATLAB allows us to get the inverse of an invertible matrix. So that means a matrix which has an inversion, that function will return the inverse of it. So let's demonstrate it. So let's demonstrate matrix inversions in MATLAB. So let's start with a simple matrix. So B equal. Let's start with a simple 3 by 3 matrix. So B equals 3 by 3 matrix. It's not necessary to always include the comment, but just to show you just what is going on. I add the comment to it, but it's not necessary. You can just go right and do it. But knowing how to write comments too or developing the habit of writing comments too is very, very essential. You so let's populate our matrix. Let's see 4, 3, 2, 5, 5, 1, semicolon, 2, 4, 3. So we have 3 by 3 matrix which is assigned to the variable b. In order to find the inverse of b, so let's see b underscore inverse, we call it b inverse equals we use the function called, I don't know if I should call it inv, or but the function that we use is inv. Then you pass the matrix to it. So in order to find the inverse of a matrix, we use this function, the IV function, or the, let's call it IV function, just to avoid any complications with the pronunciation. So we use the IV function or the inverse function. So we just pass the variable containing the matrix you wish to find the inverse of as an argument to the inverse function. Then you assign it to a variable. So let's display it so that we see the inversion process. So let's first display the original function. So this, so original matrix. Okay, then invented. See the inverse of the S of matrix B, and the variable contain B underscore S, then end it with a semicolon. So let's clear the command window so that we can see the effect clearly. So let's run it. It seems some okay. Let's comment this one out so that you don't get confused, right? And let's clear the command window, right? Now let's run it. Run. No, I run. You see, this is section 1, then this is section 2. We're able to achieve this effect due to this 2 percentage signs, which I've already explained later on in the video. So if you've already watched my previous videos, I believe you already have a fair grasp of what sections are. So I won't go over sections again. So let's run the section part of the code. So run. As you can see, this is the original matrix, and this is the inverse the matrix. So one will be like, how will I know that this is indeed the inverse of this? Well, there is actually a way to prove it, and we will do it. So let's prove the inverse of matrix. According to, I don't really remember, but in matrices, if you multiply a matrix by its inverse, you are supposed to get an identity element. And we are supposed to get an identity matrix, and we all know what an identity matrix is. Basically a matrix which all the leading diagonals are all ones. So the rule, that is B star B inverse equals I, which is an identity matrix. So let's prove it. So let's say variable I equals B star B, yes, right? So let's display the results. This. So let's see. Let's first it will be star underscore. And this is a string, and I believe you all know what a string is. I've already explained it in a video under my previous videos. If you wish to understand what strings are, just need to watch my previous videos and come back and continue with this one. So this will then display the resulting values. So let's clear the command window. You can see the effect clearly. Let's see. Let's run it and see. I see that it's been underlined. So you can see. Wow, as you can see. So this is the original matrix. This is the inverse of the matrix. And when we multiplied the original matrix by its inverse, you can see that got an identity element to an element in which the leading diagonals, the elements in the leading diagonals are ones and the rest are zeros. So thus, it has been proven that B inverse is indeed the function of the original matrix B. So in MATLAB, if you want to find the inverse of an invertible matrix, so mind you, it's not all matrices that can have an inverse. In order to find the matrix of an invertible matrix, use the INV function. So you just pass the variable containing the original, just pass the variable housing or containing the original matrix as an argument to the INV function, then it will return its inverse, which you can then store it in the variable, then display it as seen, over here in the command window. If you want to test whether the result that you got is indeed the function of the original, just multiply the original function by its inverse. If you at the end you get identity matrix, which is a matrix in which the elements in the leading diagonals are ones and the rest are zeros, then indeed what you found is indeed the inverse of the original function. So now that we are done with matrix transposition, matrix inversion, let's move on to matrix indexing. So just want to create sections, matrix indexing, right? So when we talk about matrix indexing, our main aim is to explore the various ways to extract elements or numbers from a matrix, or replace elements or members of a matrix with other elements. So let's begin with sample matrix. So let's say C a 3 by 3 matrix. So a 10, 8, 10, 20, 30, then a semicolon, 40, 50, 60, 70, 80, 90. The numbers you choose should necessarily not have, let's say, the difference between them shouldn't necessarily be the same. And just choose any elements, then you use it to test it. So our main aim is to see how can extract elements from matrix. Now, in order to understand matrix indexing better, you can think of a matrix as an Excel file. So basically, let me see if I have an Excel file here. Okay, Excel. Let's open it. Let's reserve something. All right. So think of a matrix as this box is within an Excel file. So let's say we want a 2 by 2. We are considering a 2 by 2 matrix. So that's this row where each element is a cell. So just think of it like that. So if we want the elements within this cell, we will specify the row, then a column, so which is basically 1, then A1. So that's essentially what happens here. But in this case, we specify the row first before the column. So let's say we are interested in the first element. So first element, the first element of C. So the first element of C, just write the matrix followed by a bracket. Then you identify. So what you want is this first element. So this is the first element 10. You first identify the row in which we can find elements on. So we have three rows here, which is 1, row 2, then row 3. So the element 10 is located on row 1. So 1, then a comma. Then you identify on which column on that row is the element located on. So the whole of this is row 1. Then each element is itself a column. So we have column 1, column 2, column 3. So what you are interested in is the 10, which is on column 1. So just 1, then you close the bracket. So we won't suppress it. We just run. Let me clear this section. And as you can see, we extracted the first element successfully. So what if we want to extract the second element also? That is basically we want the element on column 1, element on column 2. So to do that, one will be like, see, we just need to add, since this indicates row 1, if we are interested in the element on column 1 with the elements on the element 10 and 20, which is column 1 and column 2 on row 1, basically need to add 2 here. That is true, but just adding 2 there won't suffice. We need to enclose them within square braces to indicate a range. So basically on row 1, we want the elements on column 1 and 2. So okay, and run. So as you can see, got the elements on column 1 and column 2. So if you want the elements from column 1 to 3, just move the 2 and 3. The elements from column 1, which is the starting point, to column 3, which is the end point. Then you run it. Yeah. Oh, and let's see. I think you need to add the 2 to it. So so if you want the element from column 1, column 2, and 3 to add for row 1, you want the elements on column 1, 2, and 3 to run. And as you can see, you've got the elements on row 1 on column 1, 2, and 3. But there is actually a shorthand for this one. Since you are basically retrieving all the elements on row 1, you can just remove this and place a column there. So then you run it. And as you can see, you got the same effect. So what this is basically saying is that in row 1, we want all the elements there, or on row 1, we want all the elements or all the elements occupying the columns there. So that's basically what it means. So if you want, let's see, let's do this one. Let me suppress this one. So let's consider, let's work a little bit. If so, let's say if you want the elements on the second row, let's see. As I always said, when doing indexing, the first argument present the row. So we are interested in row 2. So row 2, then it's either we use the range. So we want column 1, column 2, and column 3. It's basically column, which is basically 40, 50, and 60. to clear. Let's close the braces, right? Then we run it. So as you can see, you got 40, 50, 60. And also just move this, put a column there. Can also remove that and put a column there, then run it. And as you can see, we got the same thing, 50, 40, 50, 60, then 40, 50, 60 as well. So far you've been extracting elements from rows. And what if you want to extract elements from columns too? That too also works. So let's say on so before that, let me use this one to explain it much better. So run. So far we've been extracting elements row wise. So that is row wise like this. What if you want to extract elements column wise? What if you want to extract the element on this column instead of going like this? So basically, let's say we are interested in 10 and 40. To do that, it's basically the same thing. So to extract elements from the column is just like how the row works. You first identify the column you wish to extract the element from. So in this case, you are interested in element 10, 40, and let's say 50. But we will extract it one by one, so which is on column 1. So you can basically put a comma there, then 1. As I said, the first element represent the row. As I said, the first element represent the row and the second element represent the column. So in this case, we want to pick elements from or extract elements from within the column. So in this case, column 1. So identify column 1 and close the braces. Then you come to the row on column 1. On which element are you interested in? In this case, we are interested in the first element, which is on row 1. Just put a 1 there. Then you run it. And as you can see, n was extracted successfully. Let's clear this. So let's say, what if you are interested in the element on row 2? Sorry. So run. So as you can see, you successfully extracted the elements on row 2 but still on column 1 to 40. If you want the element on the third row within the column 1, just change this one to 3. Then you run it. Then as you can see, you successfully extracted the element on the last element on column 1 within the on the third row. So just as we did for the first one, if you want to extract all the elements on column 1, you just basically square braces 1, 2, 3, then run it. And as you can see, the whole elements on column 1 was extracted successfully. And just ignore this one and just put a column there. And this basically means on column 1, extract all the elements there. Okay, then you run it. Then as usual, has been successfully extracted the elements on row 1 or the elements on column 1 successfully. Now, what if we want to replace a certain element? It follows the same concept. In this case, it basically follows the same concept, but the only difference is, other than extracting then assigning it to a variable. So other than extracting the element and assigning it to a variable, index or other than indexing the element, then assigning the element to the variable, you index the element, then you replace it. So let me show you what I mean. So select the command window. So let's say we want to replace this first element on let's say we want to replace the first element on row 10 and the first element in matrix C. So we index it C, so it is on the first row, so row 1, then on the first column. Then we just do, let's say you want to assign, say 900 to it, so that's an obvious value, right? Now, then we try to display C again. Let's run it and see. As you can see that the first element was successfully placed with the element 100. So basically, if you want to replace any element within a matrix, first index it first, just like how you do for the extraction. But in this case, you won't assign it to a variable, but you assign a value to it. That is the value which you want to substitute for the old element. So that's basically that's basically the basis for matrix indexing. Yes, that's basically the basis. So far we've talked about matrix transposition, matrix inversion, and matrix indexing. I hope you all understood. I hope you enjoyed my video. So that brings us to the end of today's video on matrix transposition, matrix inversion, and matrix indexing. Hope you enjoyed it. And if you enjoyed it, subscribe to my channel, like this video, hit on the notification bell icon so that you don't miss any video that I post. Thank you very much. Bye bye.